Today, we will learn how to convert decimal numerals into hexadecimal numerals. The prefix des means 10, and hex means 6. So 10 plus 6 equals 16, and this tells us that hexadecimal is base 16. And that means two things. One, that there has to be 16 digits. And two, that the place value system must be based on powers of 16. Now, when I say powers of 16, what I'm talking about is 16 to the 0, 16 to the 1, 16 to the 2, 16 to the 3, and on this will go. So let's do a little example. Let's say we wish to convert the number 2020, because that's the year I make this video, in base 10 into hex. And in the real world, we say hex, but we really mean hexadecimal, because if we really meant hex, we would be converting it into base 6. So hex is just short for hexadecimal. And so there are some steps that I want to take you through to make sure that you guys get the algorithm. I'm going to move this up just a little bit so I know it's completely in frame. Okay. So the first thing you have to do, actually, I'll use this space this way. The first thing you have to do, you should always write out your hexadecimal digits. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. And that, of course, is hexadecimal. But you should know that A in decimal is 10, B in decimal is 11, C is 12, 13, 14, and 15. Now, there are 16 digits because, don't forget, we count the zeros. So there are 16 digits, and you have to know that, that there are 16 digits. And when we write out our place value, right, we're going to have 16 to the 0, 16 to the 1, 16 to the 2, 16 to the 3, and on this is going to go. And of course, 16 to the 0 is 1, 16 to the 1 is 16. 16 squared happens to be 256. And I'm pretty sure 16 to the 3rd is 4096. But my memory might not be accurate, so let's go 16 raised to the 3rd power. And yes, we get 4096. So I'm going to put this in. So this is what you need for your first step to get this whole thing started. Now we're going to do an algorithm. And if you've seen my video on encoding binary, decimal into binary, you'll recognize that the algorithm is similar, only binary is much easier than hex, and you'll see why. So this is really your step 1. Step 1 is simply to write out the place value system, which we did, and step 2 would be to find the largest place to put a value in that doesn't exceed the number we're trying to encode. So if you look at the 4096, you see 4096 exceeds 2020. So this place we can't use. It's too large. But the 256 is perfect. So we need to find out how many of the 256s will go into the 2020. So we do that by simple division. We take 2020, divide this by 256, and let's see what we get. So 2020 divided by 256 gives us 7 point something. I want to make sure this is in the field. So this equals 7 point something. And because it's point something, it means there's going to be something left over, which is good because we need to use the other digits, right? I mean, so we put the 7 in the 256 place. And then step 3, we have to find out how much is left over. So let's take our 2020 that we're trying to encode, and let's subtract our 7 256s to see how much is left over. So 2020 minus 7 times 256 gives us 228 left over. Okay, so we need now go through the algorithm. The next step would be to find the next largest place to put a value in to get 228. And the next largest place is 16. So let's do this. So let's take our 228 and divide it by 16 and see what we get. And this is step 4. So 228 divided by 16 gives us 14 point something. So the reason why I took my time and I wrote out these hexadecimal digits, even though I know you probably know what they are, is because I don't have memorized the fact that the decimal numeral 14 is E in hexadecimal. I need to see it because I don't live on a planet where, we do our math in hexadecimal as a normal thing. So I want to put a 14 in here, and I'm thinking in decimal, but the 14 is really in E. So I put that in there. Okay, so now we have to find out how much is actually left over. So step 5 will be to take our 228 and subtract our 14 16s. And let's see how much is left over. So we take 228 minus 14 times 16, and we get 4 left over. And so we have 4 left over. And so now we can put a 4 in the ones place, right? And I mean, you don't really need to do this step, but I just want to show you since it's an algorithm, right? We have 4, right? And now we're subtracting the 4 ones, which is 4 minus 4, which is 0. And the 0 tells us that the algorithm terminates. I'll just write ALG for algorithm and TERM for terminates. Terminate means finish or end, right? So the algorithm terminates and we are done. And so our final answer is 7E4. 7E4. And some of your professors might want you to put the little subscript of 16 to show that the final answer is in hexadecimal. And that's how you do it. Nothing more complicated than that. It's an algorithm, step by step. Subscribe if you like, hit the like if you like, shoot me a comment because that helps the algorithm recognize the channel, and I'd love to grow the channel. And click the notification bell if you want to be notified of new videos. Thank you.